representing systems as matrices. There are several ways to solve systems. We have already discussed some of these ways. Next, we will discuss 3 ways to solve systems using matrices instead of the algebraic method that we have done. The reason we would even want to do this would be because sometimes matrices take up less room, and we don't have to take into account the variables as much because we don't write the variables, we only write the numbers, the coefficients. So sometimes it just cleans it up a little bit as long as we understand where everything goes. So the first thing we need to do is understand the ways that we can represent the system as a matrix. We can look at it in 2 different ways. If we are given any system of equations such that a sub 1 times x plus b sub 1 times y equals c sub 1, the a sub 1, b sub 1, and c sub 1 all being just numbers, and the other linear equation would be a sub 2x plus b sub 2y equals c sub 2. So if I wanted to write this as an augmented matrix, I would have my matrix and I would write down my coefficients. A sub 1, b sub 1, c sub 1. And then my second equation was a sub 2, b sub 2, c sub 2. So I basically just eliminate the variables and eliminate the equal sign. And to represent where the equal sign went, I'm going to put a dashed line to split them up. And that is an augmented matrix. So that matrix there is representing that entire equation. There is another way to also represent a system as a matrix, and that would be what we call a matrix equation. So a matrix equation, again, we're going to just write the numbers, at least in the coefficient matrix. My coefficient matrix would be a sub 1, b sub 1, a sub 2, b sub 2. So I just write the coefficients of the actual x's and y's, and then I'm going to multiply that times my variable matrix. So I'm just going to write the x and y one time, x on top, y on bottom, equals my answer matrix, c sub 1, c sub 2. So that is a matrix equation, and the other one was the augmented matrix. So those are the 2 ways that we could represent any system as a matrix. So depending on how we're going to be solving it, we're going to want to do it a certain way. For these examples, we want to try to rewrite the system as both an augmented matrix and as a matrix equation. So this first one, we want to write an augmented matrix for 4x plus 7y equals 46 and 4x minus 2y equals 28. So we basically just write the numbers of that. So that would be 4, 7, 46, 4, negative 2, 28, and separate where the equal sign is with a dashed line. There's your augmented matrix. And now for the matrix equation, write my coefficient matrix, 4, 7, 4, negative 2, times my variable matrix, x, y, equals my answer matrix, which is 46, 28. And there's your matrix equation. In this next example, we should notice right away that our system is not in standard form. In order to actually put it into an augmented matrix or a matrix equation, we need to first put it into standard form. So that's what we're going to do. So we need our x's and y's on the same side of the equal sign. So I'm going to add the 3y on the first one. So I have 6x plus 3y equals negative 24. And if I subtract the x over on the second one, negative x plus 9y equals 23. Okay, so now that is my new system of equations, and it is in standard form, so now I can pretty easily find my augmented matrix. 6, negative 1, 3, 9, negative 24, and 23. And my matrix equation, 6, 3, negative 1, 9, times my variable matrix, x, y, equals my answer matrix, negative 24, 23. And there's my matrix equation. So remember, the first thing you always need to do is put it in standard form. If it's already in standard form, then you just go ahead and put it into your matrix form, whichever one you are being asked. Those are your notes over representing systems as matrices. Go through the practice problems. Make sure that you are comfortable with both ways and you understand the differences between the two ways, and then prepare for your quiz over the material.